Hate it. What's that? I'm sure that can end a little early. Oh, who should I talk to about it? Well, thank you for letting me know that that's what's going on. I appreciate that. Okay, so you finished number one? Like there's a little bit of struggling. I understand. You got it? We're looking for now. How do you say this? Inverse. Exactly. Inverse of g of x, or just g inverse of x. Not g to the negative one of x, or g of negative one of x. It's an inverse. So the first step would be to take your x and y and switch. Yes? So we start with this. This is the original function. And now this, we have the inverse function. So that is inverse. But we want the inverse solved for y. Yes, Ben. Eventually, yeah, there are shortcuts you can take. Yeah. But I don't want magic to happen or anything, so I just want to take it step by step so we can arrive in the correct place safely. So who could lead me through the rest, solving for what? Any volunteers? To lead me through, we need to solve for y. I just need some help with that. Okay, Naris, you want to help with that? Okay. Okay, so 3 plus y. 3 plus, and where did that come from? Okay. You what? Okay. You already solved for y? How? I just want to know how, because you can't like add 3 to both sides, right? I'm looking for a step by step, and I have a feeling you got to the arrival point because I think you have a pretty good picture of what's going on here. I'm looking for a step by step, like what's a logical next step? Could I do this, add 3, and then maybe this or something? Would that make sense?
No. No, no.
Yeah. Nope, you can't do that.
I don't think you have to do it. Yeah, I do know.
Well, I'd like to see step by step. Just to make sure we get it right. Well, let's think about what the warm-up said. Gideon reminded us that exponentials could be rewritten as logarithmic. We have, right now, this is exponential. Let's rewrite it as logarithmic. Yeah, Raquel? Nice. So it looks like you did this. You changed it into log form. Is this what you're saying? Well, are we okay with this statement? This is exactly what I'm looking for. And when you're solving for that inverse, then yes, I want you to isolate that variable. And I think, is that what you were saying? So I was misunderstanding, excuse me. Yeah, so that's the final answer here. And we're going to replace that y with g inverse of x. Are we okay with that? I want to see g inverse of x. Yeah. Yeah, I would take off a point, especially since it says find an equation for g inverse of x. It would be just a minor deduction. If there were like 5 questions that had that and you did that on every one, I wouldn't take off more than once because it's a small error. I think you would agree with that. Very small error, but an important last step. Yes, Jack.
So there's no parentheses around the x3.
Good question. Should there be parentheses around the x plus 3? I remember it came from here. Plus 3, plus 3. So there's no need to add it on to x. We're adding it to the entirety of log base 2 of x. I like that. That's a good question. Did you already finish 2? Raquel, thank you for your help there, by the way. And there's I'm trying to see your vision. Thank you.
I didn't know what I did.
Yeah, just looking for step by step. Well, once you're here, you could add 3, but I think you mentioned adding 3 here, even though I think on your paper you had already gone that step. So I was looking for just a change to logarithm. Yeah, I'm not comfortable going from here to here, quite honestly. Be careful about making big jumps like that. Did you do 2 already? See what you got. I'm going to start with y equals log base 3 of x plus 2. Okay, this person I called, I know they don't like to share answers with the class, but here we go. Neris, you help us with this one. I agree with you. Oh. Okay. Right.
So I honestly just went from x equals log 3 times y plus 4.
Times y plus 2? Of y plus 2, I think is what you mean. Okay.
And then they tag and I got -2 and then -2 x.
-2 of x. But like this? Or do you mean -2?
Oh, no,
So how do you say it? -2. Okay. Plus 3? Okay. 3. Okay. Maybe. I don't know. So you said you use your fill-in brain for this, like Okay, so there wasn't a process, there was just kind of an idea of where you're supposed to go and your hope that the pieces went where they're supposed to go. Would someone like to help out with this and verify? Yeah. And say that again. Oh, so it should be like -3 to the x plus 2, you mean? Oh, it should be +3 to x plus 2. I may have just added that. Oh, so this is f inverse of x equals this? Okay. Okay. Then we get anything different? Okay, I need a process here. Yeah, Joseph? So that's your inverse. Okay. Oh, like this, outside of that. It's hard to say that, yeah. 3 to the power, 3 to the x minus 2. Okay, like that. Okay, okay. It looks good. Well, thank you. I tried my best with my writing. We have to use a process here. We have to use a process here. We see that this, I'll call this step 1, step 2. Step 1 is what kind of an equation? It's a logarithmic equation, so we have to be able to rewrite it as exponential. The way I like to think about it is we know the base of the log is 3. So when I go to my exponential, I start with a 3 and then I just say 3 to the what? X equals y plus 2. Yeah, and I just solve for y.
Hey, there we go.
Yeah, this is just by definition. Just by definition of logarithms. And it takes some getting used to. So give yourself a break if you're not getting it immediately. It takes some getting used to, but once you get the mechanics, you're fine. And then to solve for y, we just subtract that 2 from both sides. And that y is now f inverse of x. Any questions? Yes. Okay. Characteristics of the logarithmic function in the form of log base b of x.
Wait,
Keep it back here.
I'm just confused. Why is the x going to the three?
Over here? Are you talking about in step 3?
Yeah, why is three to the power of x plus 2?
Well, let's say we have a equals log. Well, let me change the a's. Let's say m equals log base n of r. If I want to change that to exponential, I can. I know I'm going to keep the same base. It's going to be n to the. This is broken up. We don't see that. So it's n to the m equals r. Right. That's it. So when I'm looking at number 2, I see, oh, my base is 3. So I start with 3. It's not going to be 3 to the y plus 2. That's going to go to the other side. It's 3 to the x equals y plus 2. So this is like the same thing as my r there. It just equals that argument, that piece of that which is in the logarithm. Okay, day 4. The domain of log base b of x. I think we have a graph here. The domain of that green one, the domain of this green one. You see what it is? From 0 to infinity. The range is -infinity to infinity. The graphs of all logarithmic functions of the form log base b of x pass through the point. Exponentials cross through 0, 1. So logarithmic cross through 1, 0. There is no y-intercept. If b is greater than 1, then f of x equals log base b of x has a graph that goes up to the right, so it's called, if it goes up to the right, that means it's called increasing. I know. And if b is between 0 and 1, it has a graph that goes down to the right, so it's called decreasing. Graph of f of x equals log base b of x approaches, but does not touch the y-axis. Can you visualize that graph? Doesn't touch the y-axis. This line is referred to as vertical asymptote, which I know you're well familiar with. Why this is so tweaked here. I'll put it right here. Log base b of x goes through the point 1, 0, like all log functions. It also goes to the point b1 and 1 over b comma -1. That graph is way too small. Those x's, the grid. What's that? Well, whatever you like. It just, no, I mean, just trying to graph this kind of detail on here is a little difficult, but you may. And also b is a variable, or it's an arbitrary constant, so I don't want to nail it down to. Yeah, of course. I'm gonna erase this. We're not gonna deal with this one. But if I ask you for log base 3 of 3, you remember what that would be equal to? Think about it. Check with the neighbor. Log base 3 of 3. Why is it 1? Because what? There's a rule. Yeah, 3 to the power of what equals 3? 1. 3 to the first power is equal to 1. We're talking about exponents. 3, I'm sorry, log base 8 of 8 is equal to 1. So log base b of b is equal to 1. So when I plug in a b, the output is a 1. You can think about the inverse of b to the x. That would be 1 comma b. Here we have b comma 1. b 1. Here we have 1 0. And this one is 1 b comma -1. Thank you. There is a vertical asymptote right here. Vertical asymptote, x equals 0. I only care about 3 points on the graph of the logarithm. Bless you. Definitely 1, 0. That's kind of like a vertex, like a parabola. The anchor is onto that. And then b comma 1 and 1 over b comma -1. Right. If it were log base 5 of x, then I want 5, 1. Okay, let's try this one. Let's do the parent graph first. Parent graph. Y is equal to log base 3 of x. What's that? And then it's all going to shift. But first, let's do the parent function. I just want 3 points. Those points are 1, 0, also 3, 1, and Yeah, the y value is -1. 1/3 -1. And this is my parent function. We're going to take all these and move on 4 to the left. 1, 2, 3, 4. They found one. This one and this one. I also have to make sure to move my vertical asymptote. I'll make this in green. It looks like the instructions are telling us to do it in an interesting way. I think we already know that the domain is 0, 2. Sorry, not 0. It's from -4 to infinity. The equation of the asymptote, x equals -4. And graphing the function, done. Let's see what we could do, for example, 2. The parent first. Make sure your neighbor has the right parent function. I would like to call on someone to help me out with this one. And I'll help you guys too if you need it. Are you ready? Let's see who Destiny will choose. Ethan, I need your help. Can you help me with the parent function, please? Okay, 1, 0. Let me zoom into this. Thank you. Are we okay with those 3? Am I frozen? Oh, sorry, I'm frozen. Sorry about that. Are we good with those 3? Or when we talked about that 1 over b, now it's just 1 over 2 or 2 comma 1. So here we have our logarithmic function. Those are the only 3 points I care about. And then what happened to all those, Ethan? Thank you. I think I could do that. Did I do that correctly? Fairly correctly?
Yeah.
Okay. Also, I have to remember to move that asymptote, yes. Without that, you're quite likely to kind of go astray. I need you to make sure that you stay within the confines of that vertical asymptote. Okay, and Ethan, the domain. Good. Equation of asymptote. X is 1, and we already plotted it. Any questions? Okay. Ethan, thank you. It's yeah, it's usually that y-axis, x equals 0. Yeah, everything just moves when you see that plus or minus inside, it moves to the right or left. Okay, one more graph. Before we actually graph this, please discuss with your neighbor what is going to happen to the parent function here. Okay, show me if this negative right here is going to do what? Show me in gestures. Gonna flip it over that x-axis. And then this 3, show me what that's gonna do. Is it up to left?
Oh, left, up three.
Yeah, in this case, it's up because that 3 is outside the function. You can imagine that x plus 3 in parentheses would be completely different. That'd be moving 3 to the left. Okay, so go ahead and make it happen. You need 3 points and then do the transformation. Oh. If you guys work it, it's great. You have it already? Another 20 seconds. Okay, folks. We have 2 different transformations. Here, Luke, have a seat. I'm sorry. Thank you. We have 2 transformations. We have one that's that -1, the one that's a +3. So which one comes first? It's order of operations. That this negative is really a -1 times log base 2 of x. So we're going to do the reflection first and then move all those points 3 up. So like this one's going to come down here, and then that point will go up 1, 2, 3 to go here. Does that make sense? I reflect over that x-axis, then up. So 1, 0, when that reflects, it stays right there and then goes up. 1, 2, 3. Do you already have that point? And one more. This one below the x-axis will come up above it, like it would go right there, but we still have to move it 3 up. 1, 2, 3. Did I do that right? Okay. What should I do with that vertical asymptote? Should I move it up? Well, it doesn't do anything to move up the vertical line. Okay, so we are done. Except we need to draw the graph. Looks like this. I don't want to make it look like my y-axis is an asymptote, so I'm gonna keep going. Kind of like that.
And what is 1 comma again?
So yeah, the story of 1, 0. It started here,
Yeah.
stays there when it reflects over the x-axis,
Yeah.
and then goes up 1, 2, 3. But this one, first thing that it did was reflect over the x-axis right there, and then 1, 2, 3. The process is pretty straightforward. Once you understand transformations, graphing these functions gets a little bit easier from a parent function. Okay, I'm gonna let you fill in the domain, the equation, and we already graphed it. Right now it is 36. We'll resume at 12:40. That's a good time to stretch or answer questions, ask questions. Sure.
I'm always going to read that area. With my comments and working on some non-work having the same. My own son is probably like,
During the break.
can you go up a little bit?
Yeah. Is this enough? Let's just find some values. Plug in at 2. What is log base 2? Yeah, that's why the point 2, 1 there. Anytime that base matches the axis. Yeah. That makes sense?
Oh, so is that what is here?
Yeah, exactly. Element that we have log base 2 is 1. That's 0. That's why. Okay. Yes, exactly.
So that's
Yeah,
why.
exactly.
One on the here.
It's the inverse. Yeah, I'll talk about that one more time. Okay, 12:40, go ahead and finish up any conversations. Okay, before we continue, I feel like there's a little bit of frustration with this new concept, which I totally understand. Anytime there's something new, there's a little bit of a struggle to really grasp it. And I appreciate the struggle, and I appreciate your focus and attempts to say, what's going on? And if you're not quite reaching it, it's okay. It's okay. And I want to remind you that if you don't know y equals log base 2 of x, I bet you know a lot about y equals 2 to the x. Do you agree that that's kind of like a comfortable equation? Let's talk about the 3 points I expect from y equals 2 to the x. The 3 points I expect there are 0, 1. Yes. Also 1, 2, and no, 3 is good, 2, 4 is good, 3, 8 is good. The other one I want is -1, comma 1/2. So remember the 3 points that I want for the log base two are just these coordinates. But if you're more comfortable starting with the exponential to get that parent function, I'm going to take those and flip them. I wouldn't blame you. It's a good idea, actually. Kind of makes it more concrete. And then go from there to say, I trust this process. The x and y is flipped. That's going to move the graph into something that's a little bit more unfamiliar territory, but I'm okay. At least I have something to hang on to that I know is true. So I hope that helps. Okay, common logarithms. That's kind of like the logarithms you see on the street at a party. Just kidding. You don't see a lot of logarithms at parties these days. By definition, if you see log of x, that is log base 10 of x. It's just called the common log. I think it's 10 because we have 10 fingers. I think that's where it comes from. So when you see log of 100, by definition, that means log base 10 of 100. I want you to take a moment to discuss with your neighbor, what does that equal? Did you do this already? I bet you could. Can you show me what you got? Let's see. If you're not sure, we'll just say this is equal to x, right? But we don't know what it is. So now we can rewrite that as 10 to the x equals 100. And now it's a little bit more obvious to see that this is equal to 2, right? X squared. So one way I think about these logs, when I think log is 10 to 100, and to the y equals 100. And base to the whatever's there equals. Yes, yeah. And that's what's happening when I put that x there. I'm saying 10 to the what? I don't know what this is. So 10 to the what equals 100. That's just what it means. So that's how we get x equals 2 from just your knowledge of squaring stuff. With this in mind, I think you already know that b. Just make sure, check with your neighbors, see what they got. B. Now show me. It's 3. Right, so if I set this equal to x, I would say 10 to the what equals 1,000, and that's very definitely x equals 3. C equals x